Hi everyone. Good evening. Welcome back to the day two session of Oracle SQL and PLSQL. We'll wait for a couple of minutes before we get started as people are joining. Hi Manal, how are you?
Yes, yes, I can hear you.
You Was the session useful, Mrinal? The content what we covered yesterday in terms of your expectation from the course. You have any queries or clarifications or anything?
No, Venkat.
Okay, cool. Thank you. We'll wait for a couple of minutes and we'll start at 7:1. We'll start at 7:2 as people are joining. Hey, hi Lokesh. Good evening. Okay, Lokesh, were you there in the yesterday's session? You had any questions, clarifications, or anything? Yep. We'll start in a minute, everyone. You guys are able to see my screen, right? Just confirm over the chat or raise your hand for confirmation, please. Okay, we'll start with the session. It's 7:03. So let people join the session probably another few minutes. We'll have more participants would be joining it. Okay, and welcome to day two session of Oracle SQL and PL and myself Venkata once again. And I'll be walking through the day two course or introduction to RDBMS and bit of introduction onto the SQL of how we store the data and how we access the data and everything from the SQL part of it. So yesterday we covered about database management systems, and the history of databases. I would say like all the history of been like the 50 years long history, but it's just an overview like how the evolvement has happened and where we are right now. And we later talked about some of the history in terms of Oracle database, what it started and how the new advancements and the latest version what is available for us. And then we kind of understood the essence and importance of having an database per se. Okay. So just a recap. in terms of the course content and everything before we go through once again, so that anyone has any questions or clarifications, we'll make sure that get addressed as well. So this is complete 30-day course, Monday to Friday, every day 7 p.m. to 8 p.m. And in case of any queries, support, or any query concerns whatsoever, right, you can reach us out and support at logiclabstech.com, or the contact numbers provided for you. And officially kind of started the session yesterday, right? So, and the total course fees for this is 4,130, and this is a complete 30-day course for you, which will be complete hands-on driven course. And the first couple of sessions are free demo sessions. Anyone who wants to get a glance of what content we are covering it up and how we are covering it up and all the details, you can access the first 2 days. And you can uh, join our WhatsApp community link, which was shared with you already. And I believe you probably might have been in that WhatsApp community already. Okay. And from the day 3 onwards, it would be an dedicated session with paid participants. And once you have signed up for the session, there is no option of changing the batch or shifting the batch, etc., or the refund. You can access the course content lifetime, all the notes what we are going to go through, topics what we are going to go through, the queries whatever I'm going to write it through during the session as well. I'm going to share it by end of the session, and you can access them on the portal anytime. Okay, you want to walk through those videos once again, you can do that. Okay. And those would be available for you on the LMS portal. And once you are registered, you can get access to this LMS portal as well. Okay, and all the links which are provided for you already, the logiclab tech.com. I'll just glance you through the upcoming batches, and you can see all the upcoming batches which are available. And you can go through the Oracle PLSQL content, the WhatsApp community link which is shared. You can access the link, and you can get through the payment link and the course content, what topics you are going to cover. Once you feel comfortable, you can register and sign up for the course, so that you will get to the instance access and everything to start with your hands-on activity and everything. So till that point, we are primarily covering the intro sessions, and for the paid participants, from day 3 onwards, you will have access to the instance, and you can practice whatever we are teaching on a day-to-day basis, and any new concept which you want to do as a self-practice or play around, you are completely happy to do that. Okay. Okay. And coming back onto the content, what we are going to cover today is predominantly on the Oracle SQL, PL we covered about these topics, the database, data types, and different history, understanding the fundamentals, the overall agenda for these intro sessions. And we covered about types of databases. We covered about how these different types have been created in sync with the way we use the applications or develop the applications around. And then we covered about database management systems, where we covered like what are the different agents, what are different methods or jobs which are created under this database management system. It's like overall a consolidated application or a system which is designed to work independently once it is installed up and running. So you will be have complete access of the data. You will have complete access to the hardware and the software, how it works out and everything. I mean, like we covered about these components of databases as well in the earlier session, and today's session we will glance through to the relational database. Okay, so relational database again, as I said, all these different types of databases, right? These were developed in a way to match the way we work in our real life and the way we are streamlined, the way we have positioned ourselves in terms of our day-to-day activities and everything. So it is kind of designed in such a way that it would match our daily needs as well, right? Because uh, your your system or digital data whatsoever we are storing it, or application whatsoever we are developing, it is going to be the part of our life, right? So it's not a system, or it's not a different machine like initial days, right? It's now part of your life. You need to have it the way you work, the way you handle. So it has to be designed in such a way. And similar thing, so anything we see in our day-to-day life at an enterprise level, at whatever the systematic approach, whatsoever we do, wherever we have the systematic approach, a disciplined approach of storing the data, maintaining the data, and all those details, the first thing which comes up in your mind is a relational database, where you the way we define these entities, the way we define these tables, the way we add these rows or different columns, which we call it as properties or attributes, different nomenclatures to it. These are in sync in the way we work, right? So let's say I have a school management system, right? And a school ERP, for example. I would have multiple people who are multiple stakeholders involved in running the school. It can be the admin department, it can be the teaching staff, it can be the operations team, it can be a transportation team who is, it can be a finance team who is present. Different categories or types of entities which are present. Like they are employees at first place, but their roles and responsibilities, their work are completely different. So we kind of segregate these details to the minutest possible, where you will be able to add new entities or records in your system. You will be able to update these entries. You'll be able to delete or manage the data completely. And why do we need to do, right? One of the key factor of databases we learned yesterday, right? It's not just about storing some data in a digital format. It's about how quick we can do and how quick we can pull out some data or generate some analysis or build out some useful metrics which would help me to drive my day-to-day work or drive the organization. There should be a meaningful insights by utilizing the data. This relationship, whatever we used, maybe you can say between a teacher and student. Now, if I just store it as a flat data, it would be difficult for me to build the insights, right? Now I need to understand like which teacher goes to which classroom for teaching, or which grades for teaching, how many students is she interacting on a daily basis, what is uh, what is her calendar looks like, right? How many hours of effort she is putting on a day-to-day basis, are there any break time she gets it, okay, is she getting the enough time between these sessions so that she can be well prepared for the next sessions and all. So how each teacher or whoever so person, right, is placed out in the day-to-day work will be able to build out these meaningful insights. It can be a student. uh, you can have student data. I want to understand how the student is performing and how he is progressing in his learning. Right? He's making some improvements or not. I can build out all these analytics once I have a streamlined data. So if I have like very juggled data, it's going to be very difficult, right? So you need to make sure it's clear, make sure it is properly structured and accessible, and it makes your life easy. It's our household work as well, right? Now you go to your kitchen or go to any of your workplace. If it's properly arranged in a systematic manner, it's going to be easy for you, right, to manage those things, adding it or changing it whatsoever. If it is like shuffled, dropped it here and there, it's going to be difficult. It looks very messy. For each activity, you need to go through a lot of things to capture it. So it's not op- optimistic way to work as well, right? So that's the same thing what databases also have started with relation database, where whenever you have a very streamlined structure of your workflows or the business of functionalities, the first and foremost which comes up is a relational database to it. And once we talk about relational database, the next thing would be the system which manages it. Where we discussed about database, we discussed about database management systems, and we talked about relational database and the system which is developed to work in a way for a relational database management system. It manages how the tables are created, where the tables are stored, how it is secured. Okay, now who is creating it, who is accessing it, all these are part of the database management system. You need to have a system for you which is designed robust. It is able to work itself to handle all these things. And there are like multiple databases which are available for us, like Oracle database, MySQL, or at Microsoft SQL Server, or Postgres, whatsoever. And so we have multiple different versions. Like it's not going to be a monopoly with one system. There are multiple systems, and each have their own plus and minus. The way they handle the data, or the way the uh, algorithms are written, how they handle, how they store, they have their own unique uh, uh, properties for itself, right? So they have their plus and minuses for it. So accordingly, same with Oracle as well. Oracle even today is one of the leader in terms of the database, be it cloud database, be it on-premise database, be it an enterprise level database to handle huge data, billions, terabytes, zillions of data. So for the first application with system which people have been following or using is Oracle. So that's how it is placed, and it's kind of evolving. So it's not that only Oracle does it. There are systems who different applications like MySQL, Microsoft SQL Server, which also does it. So based on the variations which fits into your business in the way your ecosystem is built, accordingly you can choose the one which fits in you to the right way. And whatever we talked about, managing all these database is taken care by the RDBMS. And what are the RDBMS features, right? Some of these features are not specific to RDBMS, but these are more streamlined and structured from the RDB, the when RDBMS has started. The first and foremost feature or property here is the ACID support. Okay. When I say ACID support is the atomicity and integrity of your data. When you need to be sure and clear, the data is not junk data anywhere. Whenever you have some update, you are doing it, you need to be make sure that system the right data is saved or into the tables when it wants to save the information, and when I want to revert some information, I should be able to revert some information as well. So the the atomicity of the data which is getting created or updated need to be maintained in a logical and systematic way. So that what covers under the ACID support. And the multi-user access, right? So when I say I have an enterprise level application, it looks very good. It's very saying that overwhelming, saying that I have a very big application which handles huge amount of data, lot of things, right? But is the data is the database accessible by multiple users, multiple roles, multiple responsibilities? Is it structured enough to handle this sort of requirement where if one person might have multiple roles, multiple activities he performs? It has to be structured in a way where it can handle multi-user access simultaneously as well. And we come about data durability, right? You should be able to data whatever you are storing, it has to be durable, right? So it's not that you're going to just place the data, it's not durable for you in terms of stability of your database or the data, no one is going to buy it, right? And same thing with data consistency, right? Wherever I see the data, whether I see it on mobile, whether I see it on computer, whether I see it on cloud, whether I see it on whatever device, wherever I am present, based on the criteria whatever I am searching the data, the results which are provided from the database should be consistent. It should never give me inappropriate data, like maybe at 10 a.m. when I search the data, it says like maybe at 2000 records in a database. Maybe the next second, if I see, it says 2500 records in a database. That difference is fine, but it has to be a legitimate difference. And whether I'm searching at 10 a.m. from a mobile, from a different device, whatsoever, the result I'm getting should be consistent. If there is an addition of data, it should show the new data with the additions. If there's any delete, it should show me with the delete. Data I'm giving, it should be consistent across, and data flexibility, right? So you cannot get into a situation where once you have the data, and you should not be getting situation like it is not allowing me to change the data type, maybe from a string or maybe to a number, or a number to a string, or maybe to a data type, maybe a timestamp, whatever are the realistic possibilities in terms of the data types which a potential user uses it on the day-to-day life, it should be flexible and should be able to handle that. And the foremost important feature, as we're talking about the RDBMS, the hierarchical relationship, the parental relationship, or the foreign key references also ever. The hierarchical relationship need to be maintained. That's where the consistency and the differences between entity comes in picture for you. So probably I'll hold on a minute on this slide, and in case any questions, any clarifications, please do speak out, or you can raise your hand or comment on this chat window as well. Whatsoever questions you have it, feel free to comment over the chat window. Okay, probably I'll jump on to the next script. And what are the benefits of these features? Whatever we do it, the flexibility, right? It's easy for you. You can have any type of data. You can add it. You can delete it. It has to be flexible for you, right? It shouldn't come back and say you should store only 10 characters string, not more than that, not less than that. You shouldn't have that control because those are not the practical possibilities. It has to be flexible for you. The asset compliance, the atomicity, consistency, and isolation, and the durability. Altogether, what we call as asset properties or asset support, and ease of use. It has to be easily accessible for you, like just like a simple any person who may be a small understanding or how to interact with the database, he should be able to use that. So the ease of use, whether you whatever be the complexity you want to uh, uh, walk it through, and whatever the uh, uh, details you want to walk it through, it should be easily understandable by any person, and multiple people should be able to collaborate, access, create, update, or read from anywhere. It should be accessible for multiple people. And the built-in security, what we discussed, the role-based access, based on the role hierarchy, whatever we have it, he should be able to access only that relevant information which he is supposed to see. He should not see any additional data. He should not see any less data. It has to be appropriate based on his role. The role-based access policies and security are inbuilt for you. And database normalization. So when I talk about relational database, right? So if I take about an employee record, this his journey of an employee is going to be huge, maybe like years long journey in the organization, starting from day one till day end. You cannot maintain that information in one single row or a record anywhere, right? So you need to split that information in multiple chunks, which is easily accessible, updatable, and the individuality of that particular data is maintained. There's no interdependency to modify or access unnecessary data anytime. So that individuality need to maintain. So we would normalize the table instead of having one table of, let's say, 1,000 columns, maybe 100 columns. Only certain columns might be interlinked with each other, falls in a particular category of data. Maybe other columns might fall into different category of data. So it's always good to segregate the information to the level of granularity which is required. It's nothing wrong to maintain one record of having all the details of an employee or a student or an individual person. There's nothing wrong in it. But it more and more you try to adopt to the realistic world, it becomes complicated. You will not be able to handle so many variations of it. So when we come to the table design, we would understand about database normalization, and we would understand how the first level normalization is created, second level and third level, where the granularity is maintained. Eventually, more the granularity, more the ease for you to have flexibility and durability in your model. But eventually it has its own concerns where more the granularity, it's going to be difficult to have a reporting sort of data for you, right? So that's where we come across different types of databases again, like transactional database and data warehouse, where application to run it faster, we try to segregate it into granular level. And for data warehouse, where we do analysis of tons and tons of data, it doesn't really matter to have that in a third level normalization in that scenarios. We try to club it together and keep it a easy access record sort of functionality. So we would come across when we start with the table designs and everything, we would discuss about database normalization, and we'll discuss about how we are converting it, how we are understanding the requirement, and how we identify different attributes or columns which are needed for a particular entity, and segregating that into different tables. And again, the granular, how the granularity can be maintained. We will cover when we start with the use case. While we design the data model of our use case, we would discuss about the normalization more in detail as well. Okay. I'll pause in for a minute here. Let me know in case of any queries, any clarification, any confusion about the topics what we covered till now. Okay. Okay. Feel free to chat, present your query on the chat. Completely fine, no issues at all. And any questions, feel free to get it clarified without going ahead with some doubt in the mind. Please raise your question. Happy to clarify and make sure the concept is clear for you. And we come into the structure how we are going to store the data in the RDBMS, right? So as we started the RDBMS, we store the information in a more streamlined way. So when I say streamlined and properly arranged data, the first format which we come across in the mind is a table-like structure where I have multiple columns and multiple rows, which predominantly we use for storing different records, etc. And all the columns, which kind of provides you the unique ability or what we call here as uh, uh, attribute of one particular each entry or each unique entry, whatever I have it in the table. So it's a matrix like format to simple understand. And we have table name, we have rows, these multiple rows whatever we see here, we call it as uh, rows. And whatever we have it, which defines the unique properties of each row, these labels, columns, properties, attributes. Different databases or different people have different way of using it. In simple, we can call it as attributes or columns. Okay, we talk about what are these each attributes which makes this record unique for itself. Let's say I have a product table, and each product has its own name, price, the category where it belongs to, and the manufacturer where it comes from. There could be few more columns with it, right? So it can happen based on how, what level of information you store, what level of information you want to access it and make use of it. Accordingly, we would s- create these columns and store it. Like storing unnecessary data is not a good idea. So when you store some information, we need to be very sure that we use the information and make some business insights using that information. and each rows whatever we discussed are nothing but tuples in technical terminology of RDBMS, but in general developer terminology, we call it as records or rows also. And this in simple we call it as one table in SQL or RDBMS. So when we create multiple tables, we'll come across those relations and everything in detail to it. And the table structure, whatever we are defining, right? So that is nothing but similar to schema or the skeleton of your data model. So you are building a data model like this is my table. It can consist the product details. It can store all this information. Maybe you might have an order details, and you would store all the different details of orders, which an order would consist. And you might have customer details. You will have a table for customer where you maintain all the unique attributes which a customer would require, right? So all this, the skeleton which I am building it, we call it as a schema also. And that's the table where we have all these columns which are defined, and as we add the data, it gets added to this table in form of records. And all the things whatever we mentioned are basically the attributes of it. And of these attributes, there could be some unique attributes, right? Some specific unique attributes which would identify my entry, where mentioning these details, out of a billion records, I should be able to get only one record, which has to be unique for itself. This we call it as the unique attribute, and there are different variations of it like non-unique attribute, unique attribute, and we use indexes and we use primary keys, etc., etc. Once we come into details of creating these tables, creating these relationships, we would come and explain more in details of how we build it. So when it comes to just in simple, in a written format, where you want to document your schema and all, this is how we potentially document this. So maintain the table name and all the columns, and accordingly, if it's a unique or a primary key, which is a uniquely identifiable attribute in your table, we underline that information as well. This is like more from the documentation perspective. So just for read, being some your readability and everything. So we talked about tuples, we talked about records, we talked about table, we talked about attributes, we talked about the benefits, and we talked about features of RDBMS, and we talked about like in general of RDBMS till now. So that kind of gives us a little bit understanding of what is RDBMS, what is table, how, what are the attributes, sort of things which are available for us. And we talked about a user access language, right? A language where user can interact with the database and do some activities in the database, right? So it needs a language, just like you have a Unix shell scripting, you have C language or a C++ or Java, whatsoever language. It's one interface for you to talk with your system based on whatever you use from your access language and coding language. Similarly, from the RDBMS, SQL is the language for you to interact with your RDBMS. So it's called a structured query language at a very basic level. Okay, and we talked about RDBMS and SQL. We talked about SQL. We talked about RDBMS. We talked about SQL. We talked about SQL. We talked about RDBMS. 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 We talked about SQL. We tal Hey, hello. Hey, are you guys able to hear me? Just please confirm. I just got disconnected. There was a sudden power off at my place. Is my voice clear and audible for you guys? Just raise your hand or confirm it over the chat, please. Okay. So we were discussing about uh, the RDBMS, and we're discussing about different type of commands and everything from the uh, SQL side of it. And so the next topic into the SQL, we would talk about more in terms of the types of command in SQL which are available for us. Right? So which are predominantly the data definition commands or data manipulation commands and the transactional control commands. So we discussed about schema, right? The skeleton which is required, which is used for storing all our information. Now we are basically defining the skeleton for you, defining the data model for you. So these type of statements which controls the schema types, schema definition. So the object definition, data, creating a table or modifying a table, which is nothing a table, or gate for deleting the data completely from the table, or creating any database object. All these we call that as so all these in terms of controlling a transaction or sequence of transactions. What we have it to maintain the atomicity in the data. We use the transactional control statements. Now we would, once we start with the data table definition and handling, getting into the queries, doing all the work, we would know about all these three different types of command, and these are going to be our day-to-day work as well going forward as we progress. Okay. and I'll pause in a minute here in case you have any question, any clarification. Please do let me know. Okay, if no other question, probably as we talk about different data types we want to store the information, right? It has to be matching with our real life scenarios. We have different types of data: integer data, float data, decimal data, currency. We have date, we have timestamp, we have string, we have small strings, we have large strings, we have binary data. All these are the different data types we handle in our day-to-day digital life. So the database should be able to handle all these variations, and in terms of storing the data, it should be flexible for me to provide multiple data types where I can store the information which I use in a real time scenario. And as we talked about, each attribute, each column have its own atomicity, and that's why we call it as start of these databases. Tables is another flat structure of storing your data, and that's where we come across different databases like a map based database, object based database, or a graph based database. Sort of these databases which fits into the respective category of the business applications. Okay, obviously, your RDBMS alone does not fit all the categories we have in the world in the real life usage. Same way, GraphQL or object-oriented database does not fit all the use cases. So part of the architecture design, what we do, part of the data modeling, what we do, we kind of identify what would be the right database and how we want to store that database and everything as well. And before we kind of uh, uh, close, kind of end of this session of RDBMS, we covered about tables, lot of other details, right? Now, the access to this, we were talking about the SQL queries, right? And basic SQL statement, like I want to select some columns or some attributes from the table what I have, and what is the condition or which records I want to print it out. It's as simple as how we use the language in our day-to-day life. So the SQL also is kind of designed and built or developed to match our day-to-day usage of general language of communication, and it's easy for anyone who learns about SQL or who sees for SQL for the first time with some understanding, like how to map in my statements and all. He would be able to or easily understand any SQL query of it. Again, when I say any, depending on complexity, sometimes might be some queries might feel complex to some people, maybe easy for other people, right? Depending on complexity and their thought process and their problem solving skills. Accordingly, understanding of the SQL query differs from person to person. And very simple example, what we have earlier, we have created one uh, table for products, right? Now I want to uh, select some data. I can give select the column names. I want to select it out. If I want to select all the columns, I don't want specific columns, I can provide this star symbol in my query, and I can give from clause the table which I want to select it, and I want to filter the records where the category is gadgets. So only gadget related entry would come up in my table. So similarly, I can search it with the product name, or I can search with the price which is more than $20, for example. I can have my where condition accordingly, where the price is greater than or equal to $20. So I can have multiple variations in my where condition to match my business requirement or the user requirement of it. And all the syllables or the keywords, whatever you say in any SQL statement, be it PLSQL or be it SQL, those are case insensitive. Doesn't really matter whether you use lowercase or uppercase. But the case sensitive, what really matters is the data what we have. So when I'm searching with gadgets with capital G, it checks the category, the column category where the value is gadgets as is. It nothing like half matched sort of scenarios, or like the case is not matching sort of scenario. Everything should match appropriately, and everything should go based on how my query is written, whether I want to whether I'm using some regular expressions, getting some partial search, or I'm using some keyword based search, or whether I'm using an full equijoin based search with an equal simple equal to sort of thing. Based on how my logic is present, I can handle it accordingly for it. Okay, and that's kind of gives the basic understanding of the relational database and the relational database management system. And we discussed about how the tables are created, stored, and a very basic introduction onto the SQLs, how the SQLs are written, how we can interpret the SQL, and how SQL returns the data and everything. So that kind of brings an end to the topics what we wanted to cover for the introduction sessions for both databases, RDBMS, and other details. And for the next session onwards, we will get into the practical understanding of what we have discussed in terms of features and everything, and in terms of how to use it, how to manage it, all those details, right? We would discuss about all this in our day-to-day course from tomorrow onwards. Okay, so the course content, once again, in case you have missed the content yesterday or you don't have the link, you can open the logiclabstech.com website, and once you open the website, you can go to the upcoming courses, search for the course 331 or with the name SQL and PL SQL of Oracle. You have the WhatsApp community link where you can join the community, get the latest updates about the day-to-day course. Once in case any unforeseen circumstances in terms of course or delay in the session, or maybe any session which will continue for any unforeseen issues, or based off all the day-to-day recordings, assignments, whatever we upload, you would have a message on the WhatsApp community. And once you have signed up, get the access to the portal, you can find all those day-to-day recordings and practice notes, the use case details in our LMS portal. And you have this payment link where you can go through the details once again, and you can register for this course once you are comfortable to start with. Okay, so you can go to the course content, and we'll be covering all the details: introduction to database, RDBMS, SQL introduction, and creating those SQL objects, accessing with some built-in functions, and querying it, simple queries, little complex queries. I will not be going into too complex queries, but we would go to the basic and intermediate level, because the intention is covering like any person who wants to learn about databases. So we would come different variations. So from there on, it all depends on your problem solving skills, how you're going to design your query and other details. And these are the topics what we are going to cover as part of this course uh, on whole and soul. Yeah, that kind of brings us to the end. Any questions, any clarifications, any doubts, feel free to unmute yourself and raise your point. Or if you are shy to unmute and raise your point, feel free to use the chat window and message us. I'll pause in for a minute here to cover any questions or clarifications. Be it the course content, your expectation, whatsoever, feel free to raise your point. I'm happy to clarify it. Okay, looks like no questions. Cool. No worries. Okay, in that case, we will wind up the session for today here, and feel free to go to the portal once again. Any doubts, feel free to reach out to the support team for any clarifications whatsoever. And you can sign up on the course link once again. And I'm providing you the link over this meeting chat window, and providing you the payment link. Once you are comfortable to go ahead, you can use this payment link and register for the course. Okay, cool. We will wrap up this session here, and I'm hoping I will see you guys for tomorrow's. And this is going to be pure hands-on session. We'll be covering a lot of use cases and hands-on exercises. Okay, thanks a lot, guys. Have a nice day. Bye.